Hi, this is Dr. Goldstein, and I am going to be discussing the concept of differentiability. So remember that the derivative of a function at a point x equals c is defined to be the number f prime of c, which is defined as the limit as h goes to 0 of f of c plus h minus f of c divided by h, and we get a number for this provided that the limit exists. And so this is kind of a big deal, right, limit existing, because if you plug in h equals 0, this limit is going to be f of c minus f of c divided by 0. These limits always have the form 0 over 0, which is an indeterminate form. So these limits may or may not exist depending on what f is and depending on what c is. So this is what differentiability is. A function is differentiable if this limit that defines our derivative exists. So the idea behind differentiability is that f is differentiable at x equals c if its derivative exists. If its derivative f prime of c exists. Meaning, when you take this limit and you evaluate it, do you get a number or do you get something that is undefined? Do you get infinity? Do you get negative infinity? Do you get different limits from the right and the left? That is the question. So let's reiterate some of that. Let's remember what it means for a limit to exist. So a limit exists precisely when the left limit and the right limit, h, not x, are equal to each other. So we have to take the left limit, f of c plus h minus f of c over h, and we have to compare it to the right limit, f of c plus h minus f of c divided by h. So if these are equal, if they both exist and they are equal, we have a limit. So if the right and left limits exist and are equal, then the two-sided limit exists. And remember, the two-sided limit is precisely what we are calling our derivative. That was f prime of c. So we examine the limits from the left and the right in order to determine whether our limit exists. And so one thing to recall is that this limit represents visually the limit of the slopes of secant lines. So what we're doing when we look at the left and the right limits is we are looking at, so when we take the limit as h goes to 0 from the left, we're looking at the limit of slopes from the left, and if we take the limit as h goes to 0 from the right, we're looking at the limit of slopes from the right. And we're going to look at a picture to see exactly what I mean by that. So, for example, let's look at the function f of x equals 2x squared plus 1 when x is less than or equal to 0, and 2x squared minus 1 when x is greater than 0. And I have drawn a picture for you. So, again, the question is, does this limit exist? And this function is weird at x equals 0. So when x is equal to 0, we can see from the picture that f has a jump. And so that's some sort of point of interest. We can ask ourselves, is f differentiable at x equals 0? And we ask, is x differentiable at x equals 0? We are looking at f prime of 0, which is this limit as h goes to 0 of f of 0 plus h minus f of 0 divided by h. That's what we're looking at. So we know that f of 0 is this point right here. So this is the point 0, f of 0. So when we look at slopes of secant lines, we are looking at some extra point over here and the slope through that line. And we drag that point in and we look at the slope of this line. But on the other hand, we could look at this point over here and look at the slope of this line. And we could look at this point, we could drag that in and look at the slope of this line. So all of these purple points and the purple lines are what happen when we look at h going to 0 from the left. All of these points are to the left of 0. And the green points and the green lines are what we get when we look at the limit as h goes to 0 from the right. And I will show you a better visualization of this using a computer-generated image, but hopefully if you look at this and you think, okay, what happens if I drag the purple points in? I'm going to get one line. And if I drag the green points in, I'm going to get a very different line. So here, the idea is that we get a different tangent line as we drag points in from the left and the right. So f is not differentiable at x equals 0. The idea is that we get a different tangent line from the left as from the right, and so we do not have one tangent line, we get a different value of the derivative. So this, we get a different value from the left and the right, and that tells me f prime of 0 does not exist. When I take the right limit and when I take the left limit, I will get different numbers. And so the two-sided limit does not exist. And that's what causes this function to not be differentiable. And again, we are just focusing on x equals 0. We're just talking about that one single point. So I would like to show you guys a computer-generated picture of this so that you can see a little bit more what's going on. So again, this is the exact same function. I have 2x squared plus 1 and 2x squared minus 1, and the break is at 0. So what happens here is if I take this point and I drag it in, I'm taking my secant lines from the left, and you can see that they're getting closer and closer to a horizontal line. So again, I'll go farther away, and if I drag that point in, my secant lines are getting closer and closer to a horizontal line. Now, on the other hand, if I start from the right and I drag my point in, if we do this, my secant lines are getting steeper and steeper and steeper, and I'm actually getting closer and closer to a vertical line. So in this case, this right-hand limit, that's the slopes of these lines, that right-hand limit is actually going to go to an infinite value. My left-hand limit goes to a finite value. My left-hand limit, I just have slopes that are getting closer and closer to 0. My slopes are getting closer and closer to 0, so my left-hand limit goes to 0. But my right-hand limit, my slopes get steeper and steeper and steeper and are going to go to infinity. So here we can see the left secant lines and the right secant lines do not match up in the middle. They don't go to one single line. So there is no tangent line. Let's turn off the picture a little bit. If we just look at this graph, there is no tangent line at x equals 0 because you don't know which part of the function to follow. So that's the idea of differentiability. Do I have a tangent line at a particular point? Does this derivative, that is this indeterminate limit, does this derivative exist? That is differentiability.